So for this question here, we've been given a 0 and 2 points. So we have three pieces of information, so we should be able to piece this together. Now, we have to decide whether we're going to use the general form, the factored form, or the graphing form, or the vertex form. So in this case here, what we kind of are leaning towards the factored form because of that 0. However, notice that we do have symmetrical points here. So at -2, 18, +5, 18. So these are symmetrical points. So we should be able to find a line of symmetry. Okay, in fact, that line of symmetry is going to be halfway between those points. If I want to find the middle, I take the average of those two x coordinates. So the average is going to be 1.5. So I do have some information to be able to do it with the vertex form. Okay, but either way I look at it, I'm going to end up with two variables. Now, it doesn't matter which method you use. You can use the form you use. You can use vertex form, graphing form, or factored form. They will all work because we have enough information to make it work. The difference is one form lends itself to a simpler solution than others. In this case here, it's kind of a toss-up because we could possibly go with a graphing form and we have a 0 for the factored form. So we're just going to try this one with the factored form to start with. So y equals, we don't know a, we have one factor, and we are missing the other factor I'm going to call m. So we have two variables, we have to set up two equations, so we do have 2 points to set up the two equations. So I'm going to start with equation 1 here, y equals 18, when x equals 5. So I input 5 minus m. So this simplifies to 18 equals 5a minus 1am. Okay, so I have two variables now. It's a bit of a problem because these are kind of bonded together with that times. Okay, so that might be a problem, but when we put this one, the other coordinate in, when x is -2, we get a. -2 minus 4 is -6. Then we get -2 minus m. Okay, and I'm going to simplify this one. I get -6. Oh, that's going to be positive 12a. Okay, 2a times -6 times -2. And we get -6 times a times -m is going to be plus 6m. Sorry, plus 6am. So we probably want to get rid of this am variable because they're kind of bonded together, and that allows us to get rid of, essentially just lets us get rid of the m variable. Okay, rather than isolating the m and getting rid of it that way, it looks like it's much easier to just get rid of the am variable, a times m. So I'm going to start with equation 2, and I'm going to subtract or add equation 1. Okay, so I'm just going to start with equation 2 here. I'm going to multiply this by 6, so I end up with 108, 30a minus 6am. Add those together, I get 126 is equal to 42a, and then allows me to solve for a. A equals 3. I can back substitute to solve for m. Okay, so I'm going to plug it back into equation 1. I get 18 equals 5 times 3 minus 3 times m. Solving for m, I end up with 3 is equal to -3m. m equals -1. So there I've solved my graphing form, sorry, my factored form. A is equal to 3, x minus 4, x plus 1. Okay, so it looks like, and my picture looks fairly accurate. That looks like that could possibly be a -1 factor. Okay, so that's one solution. I could also set this up knowing the vertex. Okay, so I do know my vertex is at 1.5. That's all I know. So I have y equals, let's see here. ax minus 1.5 squared plus q. Okay, and I can plug in my 0 to get my 1 equation. So I'm going to plug in y is 0 when x is 4. And I end up with an equation that looks like this. 0 equals 6.25a plus q. There's one equation. My second equation, I'm going to plug in one of the coordinates. So I get 18 is equal to a. It's going to be 5 minus 1.5 squared plus q. Okay. And I end up with, looks like it's going to be 3.5 squared. 3.5 squared is going to be 3.5 times 3.5. I think it's going to be 12.25a. Okay, plus q. Okay, so there's my second equation. I'm going to subtract equation number 1. So 0 is equal to 6.25a plus q. That gives me 18 is equal to 6a. A is equal to 3, okay, which we solved for previously. Back substituting, I can solve for q. So plug it back into 1, I get 6.25 times 3 plus q. I end up with q is equal to, it looks like 18.75 negative. So there's my equation in the graphing form. X minus 1.5 squared minus 18.75. And again, when I look at my graph, that looks about right. It's going to go well below the, well, this is, my graph probably should be a lot more narrower, but the vertex is going to be at 1.5 and negative 18.75. So this would be an alternate solution. It looks to me, I would think that maybe this, depending on your perspective, but using the factored form seems to me a little bit easier. But again, there's a bit of a toss-up. We can always make it work. We could even do a third solution using the general form. That clearly would be the more complicated of the three solutions. Okay, so the choice of what type of equation you're going to use, factored, graphing, or general form, depends on the information given. And really, it's not the end-all be-all, but we want to choose one which seems easier than the other. So this one seems to lean towards the factored form, so we use the factored form to solve this in the first place.